All right, we're going to take a look at our lesson titled Lesson in Chapter 2. It's Lesson 2.6. We're going to look at properties of equality and congruence. So your goal is to start using these properties. What you're going to find is that when we get to the algebra portion, you've been using these properties all along. We just weren't really using their names. And so now we're going to introduce you to some of the more formal definitions of the properties. So let's take a look. We've got three properties that we use quite a bit in geometry, and we're going to use these as we start to look at doing some proving. We talked about theorems are statements that are proven by other true statements, and so these are the true statements that we use. So we have what's called the reflexive property, and I think of that as like a mirror. It's the same thing on both sides. So AB equals AB is equality equals, so the measure of angle A equals the measure of angle A. For congruency, we're just saying that they're congruent. So segment B is congruent to segment AB. Angle A is congruent to angle A. Symmetric means if you take the whole statement and fold it in half, they'll match up. So if AB equals CD, then we can reverse that order and CD equals AB. So symmetry, we fold something in half and it's the same on both sides. So for equality, if the measure of angle A equals the measure of angle B, then I know the measure of angle B equals the measure of angle A. So these two, they would fold up if we wrote it in one long sentence. Congruency is going to look the same way. AB is congruent to CD. Segment CD is congruent to segment AB. If angle A is congruent to angle B, then angle B is congruent to angle A. And the transitive property, this is kind of how we move through statements. Similar to what we saw in that laws of syllogism, where you kind of cut out the middle part. So if AB equals CD and CD equals EF, we can cut out CD and simply say AB equals EF. So if the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, cut out your middle, and then you know a measure of angle A equals the measure of angle C. Congruency is going to look the same way. Segment AB is congruent to segment CD. Segment CD is congruent to segment EF. Cut out your middle. AB is congruent to EF. Angle A is congruent to angle B, and angle B is congruent to angle C. Cut out your middle. That means then angle A is congruent to angle C. I think of that transitive property for some reason, like I think of transitive and train, and everything, it's showing us how things are connected and linked together, kind of like the cars on a train. All right, so now we're going to take a look at using these properties of equality. And actually not using them, just recognizing them. So we have DE is equal to DE. It's the same on both sides. When I look in a mirror, when I see my reflection, it's the same. So for this first one, this is the reflexive property of equality because we have the equal sign. Now when I look at this, I have angle P is congruent to angle Q, and angle Q is congruent to angle R. What I've done here is I've cut out the middle and just said angle P is congruent to angle R. So this is the transitive. We have that long link. Property of congruency. We are going to make sure we're looking at the difference between being equal and being congruent to each other. All right. So here's our checkpoint. We're going to do this together as our warm-up tomorrow. So we've got DF is equal to FG, and FG is equal to GH. Then DF is equal to GH. We have angle P is congruent to angle P, and then we have the measure of angle S is equal to measure of angle T, and the measure of angle T is equal to the measure of angle S. What I want you to do at home is to decide, is this the equality or congruency property? And then during our warm-up, we'll name which one goes with that. So make sure you put congruency or equality before you come to class. All right, so we're going to now take a look at using these properties to define what we're doing. In a diagram, we know N is the midpoint of NP. So if N is in the middle, I know MN is congruent to NP. And then I know P is the midpoint of NQ, which means this is congruent to this. So what I want to show is MN is congruent to MP. So I know MN is equal to NP. That's my definition of midpoint, so that's what we're going to fill in there. I then know that NP is equal to PQ. That was the definition of midpoint that we had from here. So we're using our two definitions of midpoints. So now what we have is MN equals PQ. What happens is if we look up here, we cut out the middle. And so that linking is the transitive property. Here we're saying things are equal, so it's the transitive property of equality. In example 2, there's an explanation for each step in the solution. In general, what can be used to explain steps in a solution? So what do we use there? Well, what we're going to use in geometry, we're going to use our theorems that we talked about. We're going to use our postulates. We are going to end up using definitions of words, the definition of midpoint. And then we're going to use those properties, the ones that we just started taking a look at. All right, here's our checkpoint. Angle 1 and angle 2 are vertical angles. We can see that they are making that V from there. And that we know angle 2 is congruent to angle 3. They marked those angles as being congruent. What we need to show is angle 1 is congruent to angle 3. This will be your warm-up in class. But if you can, start looking through what we know for things in there. All right. Now we have our algebra properties. This is how we solve our equations. So we solve equations using addition, subtraction, multiplication. So if I add the same number to each side, so here to undo the subtracting, we add 3 to each side. That's our addition property of equality. Here I have to subtract 5 from each side. So I have 11 minus 5. And then here I've got my multiplication property. To undo multiplying by 1/4, I multiply by 4. So if you multiply by the same thing on both sides, it's the multiplication property of equality. If you subtract the same number from each side, that's subtraction. And then we have addition. We then also have the division property of equality. So if we have 8x, we have to divide by 8. And usually this is what we'll have it take a look like. All right, but we can put divide by 8 on both sides. As long as we divide by the same number on each side, our equation stays true. And then we have the substitution property, where we said if x is equal to 7, if I have 2x plus 4, then I can plug in 7 for x, and I can say that's the same as 2 times 7 plus 4. So let's take a look at how we use these properties as we go through things. We're trying to justify the theorem. It looks like I am missing a diagram in here, so I apologize for that. If we take a look at the diagram, we have angle 1 over here. We have angle 2, and then angle 3. All right, so it says angle 1 and angle 2 are both supplementary to angle 3. Remember, supplementary means add to equal 180. All right, so show that angle 1 and angle 2 are congruent. So I know I should probably look at some of my congruency properties. So here we take a look. The definition of supplementary angles, the measure of angle 1 plus the measure of angle 3, is equal to 180 degrees. And we know that because angle 2 is also supplementary, that I need to say the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. So when we look at this, I can use substitution. Okay, we can use that substitution property. And what we just did there is because angle 2 plus angle 3 equals 180, I took angle 2 plus angle 3 and substituted in for that 180. So we're taking this sentence here and plugging that in for 180 and putting it there. We then say, okay, remember, if I subtract the same thing from each side, so if I subtract the measure of angle 3 from each side, that's our subtraction property of equality. And what that leaves me with is the measure of angle 1 equaling the measure of angle 2. Well, if two angles are equal, that means they're congruent, and that's our definition of congruent angles. All right, you guys do have a checkpoint to take a look at. This is often what your problems like this are going to look like. Fill in the blanks for a matching type problem. So this will be one again that we do as our warm-up. All right, good luck with this.